Hey, all, today we are going to start talking about right triangles, and we're going to start that discussion with the Pythagorean theorem. So hopefully the Pythagorean theorem is something that you've seen before, since we did discuss it a bit earlier this year. But if you don't remember, it's a little fuzzy. The Pythagorean theorem looks like this. The Pythagorean theorem is a relationship between the sides in a right triangle. And these letters represent the lengths of the three sides in a right triangle. And the most important, the unique length would be the length that we call C. This one that's on the right of the equal sign all by itself. This is always the hypotenuse. The hypotenuse is always across from the 90-degree angle. The hypotenuse is always the longest side. So we call it the hypotenuse. It's across from the 90-degree angle, and it's always the longest side in the triangle. And so you might be really good at manipulating the Pythagorean theorem to solve for a missing side, which we're going to do. And you might do a bunch of really good math, but the one place where it's easy to make a mistake, and I'm going to hopefully coach you out of making that mistake, is not putting the numbers in the right spot. And specifically, the hypotenuse value is what we have to get right because it is the special length. And so let's look at this first triangle on number one. The first thing I want to establish is which one of these sides is the hypotenuse. So the hypotenuse is the longest. It's across from the 90. So if I were standing here at the 90-degree angle and I were to walk across the triangle, through the triangle, I'm taking a walk, I would end up over here. I wouldn't have to walk across this triangle to get to this side or this side. I'd have to walk across the triangle to get to this side. This is my hypotenuse. And so what I would recommend you do is label this with the letter C. The other two sides are called legs. And it doesn't matter which leg is A and which leg is B, because when we add these two legs together after squaring them, it doesn't matter which order you add in. So whenever we have a formula, I like to say, write the formula, write the equation, write the relationship every time. And let's plug in what we know. I labeled A to be 6, so I'm going to do 6 squared. I labeled B to be 10, so I'm going to do 10 squared. And I'm going to label C, or I labeled C, which is X, so we have X squared. Another easy place to make a mistake is to forget these exponents. We are squaring all of these lengths, and we can't forget to do that, or else we will end up finding a wrong answer. If you don't know what 6 squared or 10 squared is, that's totally fine. We can use Desmos. 6 squared is 36. 10 squared is 100. We simplify that. And now we don't really want to end with just x squared. We want to know how long x is. We want to know how long is this hypotenuse. The way that we cancel out a squared is by square rooting. Square rooting and squaring are opposite operations. And so if we square root x squared, we get x. And hopefully that you know from algebra, whatever we do to one side of an equation, we must do to the other side of the equation. We're currently working on simplifying square roots in class, so we're going to work on that a bit more together. For now, we're going to leave this like this, but in the future, I'm going to ask you to simplify that square root as best you can. But we'll work on that in class together a bit more before I ask you to do it right now. So for any right triangle, if we know two of the side lengths, we can figure out the third side length using the Pythagorean theorem. This only applies to our right triangles. I'm going to go figure out which is the hypotenuse. It's across from the 90, so I label that C, and my other sides are A and B. If you label 7 as B and 13 as A, that's totally fine. Like I said, they're interchangeable. And so I'm going to plug in here what I know. A is 7, don't forget to square it. B is 13, don't forget to square it. C is X, don't forget to square it. And if you need Desmos for some help, that's totally fine. Don't be too proud. Go ahead and use that tool that you have at your disposal so that we don't get any arithmetic or multiplying or squaring errors. I'm going to add these two together. And of course, if I happen to make a arithmetic error here, feel free to let me know so I can correct my mistake. Again, in order to get rid of that squared on the x squared, let's square root both sides. This squared and the square root cancel, so I'm left with x on the right, and then here it's the square root of 218. If we don't put this in the calculator or we don't simplify it, that square root can't go anywhere. It still needs to be there. It looks a little uncomfortable maybe to have that symbol, but it's not wrong. The square root of 218 is just a number. I'm going to do one more, I think. And I'm going to choose one that has a square root in it. I have a right triangle. I'm looking to figure out one side length, and I know the other two. So I can use Pythagorean theorem. I'm going to figure out that this side, that's square root of 15, is my hypotenuse. So we're going to label it as C. And then we can label these as A and B. It doesn't matter which way you label them. Let's plug in what we know. I said A was 2, so don't forget to square it. B, I said was X. Don't forget to square it. The square root of 15 is C. I'll say it again. Don't forget to square it. Now I want to simplify my numbers before I go solving for X. So 2 squared is 4. Just like we had up here, the square root and the square here cancel, and I'm left with what was underneath. The square root and the square cancel, and I was left with X. Here I have a square root and a squared. They cancel, and I'm left with 15. The square root of 15 squared is the same as the square root of 15 times the square root of 15. And we're going to talk about this in class a bit as well. We'll work through these things together as a refresher. When I multiply these two things together, I just end up with 15. So now I can solve for X by moving that 4 over. And when I move it over, it becomes negative 4. And now we're using this fact that we can cancel out a exponent of 2, a squared, by square rooting. And we have to do it to both sides. So we find our side length to be the square root of 11. Again, if these square roots as answers are uncomfortable, that's okay. We just got to get comfortable with being uncomfortable. It looks a little different, but this is a number just the same as the number 3 or 4, and it's okay, especially since we started with one that looked like that. So I want you to ask for help from one of us before trying these two problems if you didn't understand any or all of what I just said about those 3 triangles and the Pythagorean theorem. If you feel ready, then try these two. And then when you press play, you'll check your answer. So hopefully you got these 2 answers. Just a quick note that perhaps if you got the first one wrong, check to make sure that you labeled that side C because that is the hypotenuse. Or maybe conversely, if you got this one incorrect, make sure that you label this side C, because this one is the hypotenuse. So in one of them, you're solving for the hypotenuse, and in the other one, you are not. So if you got one or both of these wrong and you can't figure it out, please ask one of us for help before moving on to the practice. And then when you're ready, please do the 8 practice problems. Take your time on these. If you need us, please do ask, and good luck.